Okay, can you all see my screen?
Yes,
yeah.
All right. So I'm Marcello Herrera, and I'm here to talk about cooling water management technologies that can really be applied to many different industries, but given the state of the world right now, I want to focus on their use in data centers. But before I start talking about these technologies, I'd like to introduce myself a little better. So I am a St. Peter's School alumnus, and I graduated in 2012. And after that, I came to the University of Minnesota, where I studied chemical engineering, also got minors in chemistry and political science. Shown in the picture on the right, I'm a big American football fan. Even in Barcelona, I used to play for the Barcelona Búfals and even got to play for the Catalan team, which was very exciting. After college, I worked at Henkel for 3 years, where I helped develop thermal interface materials. These are materials that help release the heat from electronic products, and I mostly work on their applications on 5G telecommunication technologies. If there are any gamers out there in the audience, you might have applied thermal paste to your computer. This is basically what they are, but for industrial applications. And a little bit over a year ago, I started at Ecolab, where I actually did 2 of my college internships, where I now work as a regulatory specialist in global trade compliance, where I basically help ship our chemicals and our products all around the world. And even though this is not exactly an engineering job, having the engineering knowledge to understand these technologies, it's very important. So let's talk about data centers. Data centers are more important than ever, especially this last year. And if it wasn't for them, we wouldn't be able to have this conversation right now. Since we don't really see data centers often, or perhaps ever, it's very easy to overlook their environmental impact. But in fact, these generate large amounts of heat and require to be cooled down to prevent malfunctioning or even fires. But more likely, they would malfunction before they would start catching on fire. And to cool them down, these consume large amounts of water and energy. Just to give you an idea, just in the US last year in 2020, the data centers consume about the equivalent of the drinking water needs of 601 million people. That's about the population of the European Union and Russia combined. Also, I think I've come across this statistic that watching one season of a TV show by streaming consumes about 260 liters of water. I don't know how long the episodes were, how long the seasons were, but just my point is that they consume a lot of water. Therefore, it's important to have good water management, because otherwise we can have higher water and energy use that's basically wasted. And also, poor water management can lead to the Legionella bacteria presence, which can cause Legionnaire's disease. I'm not sure if I'm pronouncing that right, but then this disease can cause pneumonia, and we definitely don't want any more respiratory diseases going around. You might be wondering why poor water management leads to higher water and energy use. So well, let's talk about a chemical engineer's favorite topic, which is pipes. By the way, if any of you is considering studying chemical engineering, just make sure that you like pipes. You've been warned. One common problem that occurs in cooling systems is fouling. And fouling is essentially a change in the solid boundary. In our case, the solid boundary, it's the pipe or a cooling equipment. And these changes decrease the amount of heat transfer. We're talking about a cooling system here. So we definitely want good heat transfer so that we can remove the heat generated by those data centers away from them. So there are more types of fouling, but the 3 that I will focus today on are corrosion, scaling, and biofouling. Corrosion is a chemical reaction between metal, and in our case, the metal it's the metal pipe, or the metal cooling equipment, then water that we're using to cool down the system, and oxygen, which is dissolved in the water. And this chemical reaction generates rust, as shown in the top picture. I'm sure we've all seen rust somewhere. Scaling refers to dissolved materials becoming supersaturated. Just as a reminder of what that means, imagine you have a glass of water and you're stirring it a little bit and you're adding salt, just the salt that we eat every day. And at first you'll see that the salt dissolves, But as you keep adding, eventually, any additional salt that you add doesn't dissolve. You can see those granules of salt just going around the water. At that point, the solution has become super saturated. That's what supersaturation is. In our case of the cooling system, the water that's coming in from just the water line, like it has some dissolved materials, and maybe they're dissolved when it comes in, but the solubility changes with temperature. So now at these different temperatures that are within the cooling system, those salts might not be dissolved. So now they become supersaturated and they can form large deposits like the ones shown in the middle picture there. Lastly, there's biofouling, which is basically organisms in the fluid stream. In our case, the fluid stream is water. And they attach to the warm surfaces and they find those conditions favorable for growing and reproducing. Now it might be a little confusing, like we're talking about a cooling system, where is this warm surface? Just so that you understand, a cooling system, the way it works is it transfers heat from one place to the other. So yes, we're cooling water in some parts of it, but we're also heating up water in other places of it. So these organisms would attach to those places where the system is warmer. And a lot of biofouling can look like the picture at the very bottom. That's heavy biofouling. So in order to understand how this becomes a major problem, I need to explain a little bit of how cooling works. I'm not going to go into detail of how the entire cooling system of a building or a data center works, because that would take too much time out of this presentation. That could be a whole presentation of its own. But one aspect that it's relevant to this discussion, it's evaporative cooling. So evaporation, it's a cooling process. Imagine you're getting out of a pool or you're coming out of a shower. We start feeling cold very quickly. That's because that liquid water on our skin is taking energy from our body and using that energy to get all excited and become a gas, right? So that's what evaporative cooling is. In this case, in the diagram, we have a container with water and we're blowing air to speed up the evaporation process. So the water molecules, the liquid water molecules on the surface start taking energy from the remaining of the water. These molecules get all excited and start evaporating. So they leave this container. So we end up with a little less water, but that water that remains, it's colder because there was evaporative cooling that happened. And in a cooling system, the water that's lost through evaporation gets replaced. But the problem is that the fouling materials that I talked about in the previous slide, they don't evaporate. So their concentration increases. So now that we understand the problems, let's talk about possible solutions. One possible solution is probably the most common and most obvious solution. It's blowdown, which really just means replacing water with high concentrations of fouling material with fresh water. The problem with this solution is that the water is wasted, and we also used a lot of energy to cool down this water, so we're also wasting a lot of energy. So other possible solutions is to use different chemicals. For instance, we could use corrosion inhibitors. What corrosion inhibitors can be chemicals that react with oxygen. Remember that oxygen is an ingredient in the corrosion reaction. So if we consume that oxygen, then corrosion will not happen. Or other corrosion inhibitors, instead of reacting with oxygen, what they do is that they form a protective layer on the metal, and that way the reaction is also prevented from happening. To prevent scaling, we could also use scale inhibitors, which are chemicals that react with those dissolved materials, those salts that are dissolved in the water, and they result in new complexes, new compounds that have different precipitation properties. What I mean by that is that the temperature at which they would become supersaturated, it's different. It's not a temperature that is found within the cooling system. That way we avoid scaling formation. And lastly, to prevent biofouling, we could use biocides, which are just chemicals that kill or inhibit the growth of microbes. And with these solutions, we can have our pipes looking like the picture on the right instead of the picture on the left. And that's definitely what we want it to look like for good heat transfer in a cooling system for a data center. So, of course, this is the Singularity Foundation, and we like data and automation. So let's take these solutions to the next level. And one way to automate the cooling water management process is to use Ecolab's 3D tracer technology, which is a combination of chemistries, sensors, controllers, and software. The chemistries are the fouling solutions that I mentioned in the previous slide, but these chemistries can also be polymers with a fluorescent tag that allow for monitoring them throughout the whole system. And the way we monitor this is using a fluorometer, which is a sensor that reads fluorescence. The fluorometer in the picture, it's the white box near the center. And this fluorescence correlates directly to the amount of polymer that it's in the system. And the amount of polymer can indicate us if there is scaling happening within the system, because if there is, the polymer would be consumed. So imagine there is this chemistry is going through the system, the fluorometer is reading a constant level of fluorescence, and eventually it starts to go down. That indicates that scaling is happening and it's consuming that polymer, and that's why the fluorescence level goes down. Besides the fluorometer, we also have other probes that measure conductivity, pH, corrosion, and oxidation reduction potential. And all of these really just tell us if there's any corrosion happening in the system. Since corrosion is an electrochemical reaction, all these can give us a pretty good idea of corrosion happening in the system. All the data that's collected by these sensors gets analyzed by a controller, which is the big box on the top left of the picture. And the data gets analyzed and it gets transmitted to, say, dispensers that are in the system that dispense those chemistries. Also gets transmitted to nearby computers so that workers can monitor themselves, like look at the water quality, how it is. And it also transmits the data to a water control center, which it's really cool because it just looks like a NASA flight control center, but it's actually just people looking at water qualities of different systems. And then in the computers, we have software that can determine the optimal treatment plan for that specific process. So with this technology, we are able to detect the problem right at the moment that it starts occurring. Just when scaling starts occurring or corrosion, we're able to detect that very quickly. We're able to add just the right amount of chemistries needed to solve the problem. And blowdown, it's not completely unavoidable. So there is still some water waste. However, we can save a lot of water. We can reduce the amount of waste that there is by using these technologies. For instance, data centers can go from flowing down water every 1.8 cycles in their cooling system to every 3.3. That's nearly doubling the number of cycles that they can do. And this can save over 10 billion liters of water in a year. And that's really all I had for this presentation. This is by no means a comprehensive review of all the solutions that there are for fouling and cooling water management, but it's rather just the ones that I am familiar with from my job. And I hope that you learn that data centers have a significant impact on the environment. And I don't mean that to be a discouragement from using these technologies, but rather to show that innovation can decrease our environmental impact. And so the references I used, and I'll be happy to answer any questions.
Okay, thanks, Marcello. Those of you that have any questions, if you want to type them in the chat now, you can, and we'll be able to see them on the screen. Any of you that have any questions. I'm sure you're after alarming a lot of our students about their viewing of Netflix and how much water that actually involves. They'll think the next time how long they're sitting down to a movie. It's kind of alarming, so it is. How many gallons you said? Was it? No, liters. It was 260 liters of water if you were watching a series of Netflix. So I think none of us have ever thought that that's our water footprint in the environment when we sit down in front of the TV. There's one question here. So if we downloaded the series or movies instead of watching it by streaming, would that help to save water?
Well, I would imagine that if you are rewatching, then yes, because that as you rewatch, you're not using any more cloud data. I know a lot of people like to rewatch The Office, so maybe if you just download The Office and watch it once and have it downloaded, that's probably good. If you're just watching it once through, I'm not sure. I would guess it's the same, although I'm not entirely sure. If you're rewatching, definitely it saves water.
Okay. Anybody else there from the ESS classes with a question? Timo's question: why not use air cooling? It's more expensive. Is it more expensive or worse, or what are the benefits of using water?
Right. So like I mentioned, I didn't go into the details of how a cooling system works, but we cool down the water and we use that cooled water to cool down air, and it's really air what's blowing into the data centers to cool down the air. So water, it's like it's necessary for doing the air cooling. But yes, we do use air for cooling too. It's just that I didn't go into all the details of the cooling system.
Okay.
But in order to cool down the air, we gotta cool down water, basically.
Okay. Any other questions there from anyone? I suppose I was going to ask just about the water that you use. Is that recycled? Is that treated and recycled to go back through the system again, or is it usually just disposed of, that water
It
that
really
would go through the pipe
depends.
system? Is it like a circular system?
Right,
Or
it really depends on the system and even like regulations. Like, for instance, I think in California, like data centers now are required to only use recycled water. So in those situations by law, they're required to use recycled water, and that's also makes this technology even more important, because if their water is recycled, the quality of the incoming water, it's always different. So being able to monitor that, it's very important. I'm not exactly sure that it always get recycled. That I'm sure it really depends on the application, like where the customers have their plants and what the water availability is and all of that.
Okay.
But yes, it can be recycled.
Right. Okay. Anyone else with any questions? Antonio has a question here. What characteristics or features make the 3D tracer technology environmentally friendly then?
So the main one, I would say, it's just the amounts of water and energy that it saves just by preventing these fouling problems from occurring. But also it has been approved by the EPA as green chemistry, and that just means that it's not harmful chemicals that are being dumped into water and so on. But yeah, the main environmental benefit is the amounts of water and energy that are saved by using this technology.
Okay. Elena has a question here. Is the recycled water better or worse? And do you consider this a long-term resolution, or are there any improvements being done or thought about?
Is the recycled water better? Well, yes, because it's saving. It can save a lot of water waste. If it's definitely better if it can be done, but it might not always be possible to use recycled water, or in some cases it might be way too expensive. But generally, yes, it's better. And this is a long-term solution, or are there any improvements being done or thought about? Well, there are different ways of saving water. Like, for instance, I talked about evaporative cooling, and big data centers can just cool down their data centers using just evaporative cooling, not having to go through all this equipment of like cooling, like a cooling tower that cools down some water, but then there's another chiller that's also consuming more energy to cool more water. If you have a really big data center and the conditions in the air are adequate, which is mostly like pretty dry climates, you can cool them down by just evaporative cooling. So just have like water coming down this like big wall with like very high surface area and just blow air, and that's enough air cooling to cool down the whole data centers. But it really only makes sense in certain parts of the world, like maybe the southwest of the US, which is pretty dry. Maybe some parts of Spain would make sense. Just climate has to be fairly dry, and also to make sense, data centers need to be big. So it's a solution that makes sense maybe for the Facebooks, the Googles, and Amazons of the world, but might not make sense for all companies out there. Another very interesting solution that Microsoft is developing is to have their data centers under the ocean. They just have like a big capsule of servers down in the ocean, and of course the ocean's, it's a huge heat sink, and that's just how they're cooling down those servers. I think that's still pretty much under development. Maybe they've deployed some of those, But yeah, there are definitely other ways of cooling down data
so
centers.
they're expanding the technologies and investigating all the time.
Mhm.
Okay, we have a question here from Leo. How does the 3D tracer technology deliver a solution, whether it is corrosion or any other, I think, other problem around the system?
So the different sensors can detect what type of problem it's occurring. So for instance, if corrosion is happening, it would be detected via like the pH level or the corrosion oxidation potential reduction probes. What they read, they can tell us if there's corrosion happening and how much. And that information gets transmitted, well, it gets analyzed by a controller and it gets transmitted to a dispenser that it automatically dispenses the necessary amount of those chemistries. Then for the case of scaling, that's where that fluorescence really comes into play, because the fluorescence is like attached to these specific polymers, like the specific molecules. So if the fluorescence level starts going down, that means that material is being consumed, and that means that scaling is happening. So that's how we would know that scaling is occurring in those cases. So depending on the data that we get, the different sensors, like each sensor is meant to read one thing, and that can tell us what type of problem is happening. And then, yeah, this gets transmitted to a dispenser, and it dispenses the necessary chemistries.
Okay. Next question, whether this technology will turn recycled water into pure water in the future?
No, this is not really meant to like, I wouldn't say that this it's meant to like purify the water. Like if you want pure water, you need other technologies. This is more meant to prevent the fouling from occurring in a cooling system. And maybe in one same plant, you could have another water purification system, but that would be like in line with this, but that would be separate. This is not meant to like give you pure water.
Okay. Another question from Ariadne, is the 3D tracer only used in the US? I was thinking the same. Has it been expanded, especially for data centers?
No, it's used all around the world. And yeah, it's used in many places around the world, like including Spain. So yeah, it's in many places. And it's not just in data centers also. I just wanted to focus on their use in data centers because, like I said, like we're having this webinar and we're doing so much cloud computing lately, but this can really be used in any system, like any big building cooling system or any chemical plant, food processing, wherever there's water that needs to be managed, like this technology is applicable there.
Okay. I know I was talking to Ms. Garcia today, and she was talking about the biofouling variability, the micropopulations, and she was wondering today, how would that variability, we were saying, like, is the water sourced from a local river or lake, or is the water taken from the domestic supply that would cause the variability? We were wondering today. Or does it again depend location?
Yeah, it would depend on the quality of the incoming water, but it's not like there would be like a lot of bacteria in the incoming water. It's more like if there's a little bit, like these are living organisms and they can start growing and reproducing in the cooling system. So it's not necessarily that we're using super dirty water. It's just microbes that we're drinking every day ourselves even. They just find the conditions in the system favorable to grow and reproduce.
Okay.
Yeah.
We have another question here, I think, from Ariadne. She says, how can I know where it is? Because I think it would be very interesting to ask the school for a visit to see how it works. It's really, I suppose, is there any being used by any companies in Spain at the moment? This type of technology that you know of yourself, or Barcelona even better?
Yeah, well, I wouldn't know like which specific like customers would have it. There is an Ecolab office in Barcelona actually. So I don't think they would have this application there, but maybe I could ask, see if it's being used somewhere nearby and it could be shown. I'll ask. I'll ask.
Okay. We have another question. Do we? Yeah, we have another one. No, just a message. What is the best metal to use in the pipes to reduce the corrosion then?
Oh, well, that's a very good question actually, because another possible solution to corrosion, which I didn't talk about, it's just your selection of material. And honestly, I'm not exactly sure which would be the best. Of course, we typically use like stainless steel, but there are many different types of stainless steel, and really I don't know which one is the best, but definitely material selection, it's a factor to consider when designing the systems, because you could prevent a lot of corrosion just by using the right material. However, corrosion it's not 100% avoidable. So even if you have like really nice stainless steel, some corrosion would still happen. And so this technology still would have a place in those situations.
Okay. There was another question there that asked, what is Legionnaire's disease? That they had seen it in the presentation, but they're not sure exactly what it is.
Yeah, well, I'm not very familiar with the disease itself. I just really know that it can cause, it's a respiratory disease. It can cause pneumonia, and that's really the extent of what I know. Yeah, it could be fatal, and I really don't know much about this. As I understand, it's fairly rare, but we have these data centers that the conditions that can be kind of favorable for it to grow. So it's definitely something that we gotta be careful with.
I don't know if anyone else has any more questions.
Well, I had a question, but in fact, as you were talking, Marcello, it's been great because there's been ideas coming up into my mind. But the one that I was wondering is, so really, we're using water to cool data centers, but at the same time, we are using the information and we are controlling the information, I suppose, in another data center.
Yeah, it's possible because a lot of the data is being transmitted. Oh, yeah, like especially if that data is being transmitted to like the control center that I talked about, then yes. If it's only local, then there wouldn't be a need for a data center because it's just the controller transmitting to the nearby computers and dispensers. But yes, it's possible that data centers are being used. I hadn't thought of that. But yeah,
so really, it's a bit like a fish biting its tail somehow.
Yeah.
No, but it's really interesting also what you said, that then the larger, because usually in environmental solutions we tend to like reduce and disperse the problem, and actually you were saying that the larger the data center, the more energy it's saved and the more efficient it is for the cooling system. So it also shows that at some points there's not always one right solution, and we actually have to think about the case particularly and choose the right way of dealing with it. And it's not, usually it's like, okay, let's make it small and then no one will realize. In this case, it's like, let's do it big and then maybe it's best because we are more efficient dealing with it.
Yeah.
So that, I think that's also really, really interesting. Yeah, I mean, it shocked me, but then I was thinking, if the system has its sensors and it can actually modify the chemicals that are added depending on the problem, is it possible? And now I'm just in science fiction because this is not my field at all, but could we use then artificial intelligence somehow so that the system learns about the type of problems and can predict it even before they take place?
Yes, I think it's actually, this technology has been used in some areas, like in like municipal waters or like places that are like very water depressed. I know that it's been used because then it's like they want to know what's the best way to like manage their water. So yes, and actually like Ecolab has like partnerships with Microsoft for all this like data analysis and artificial intelligence. So yeah, it's pretty interesting, but I'm not like very knowledgeable about what exactly they do with the data, what exactly they do, but yes, that it's actually done by some people or some computer in the case of artificial intelligence.
So eventually it could even be done that you foresee the problem before it actually takes place. Wow, that's amazing. Thank you very much.
Yeah.
We have another question here from Jan. What is a biocide?
It's a chemical, like sometimes it could be some type of acids. It depends on the application, but these are just chemicals that kill or inhibit the growth of microbes. It could be, like even like vinegar could be considered one depending on the application. It's like acetic acid, like or phosphonic. It really depends, but yeah, it's a chemical and they kill or inhibit the growth of microbes.
It's coming through. I suppose this technology has expanded then, I suppose, in the last couple of years because of the water conservation and because of energy that it saves as a result, and because more companies now are under pressure to improve their sustainability and to reduce their water footprint and their carbon footprint around the world. Like, would you know anything about that? Like, let's say, have you got more customers in, let's say, the last 5 years because of everyone's companies under pressure?
Yeah, I don't know like specific numbers, but it's
No.
definitely it's grown a lot, especially in the last year. Like data centers has grown a lot, like tremendously, just last year because of the increase in use in like
People
cloud
working from
computer
home.
technologies. Yeah, I really don't know numbers to give you an idea of how much it has grown, but yeah, especially in places that they have very little water, and we have a lot of people in the world, surprisingly, living in places that have very little water. So then these technologies are becoming like very popular, just in order to preserve water.
Yeah, I saw that on one of the videos for India, for a steel mill in India. They use this technology, so they do, and water is a scarce resource in certain parts of India as well. So this technology is really important to their business there. I'm not sure if you have any other questions from anybody. We still have a good few here. Here's one more from Jan. Just to have a clear, why is corrosion so harmful for pipes?
So it's like basically the pipe is being consumed, and eventually you don't have a pipe anymore. Well, that would be very extreme, but the corrosion, it's basically consuming this metal that you have, this metal pipe. It's become rust, and then rust is not as strong, so that's why you can see a lot of rust, like cracks, when you look at a very rusty pipe or very rusty metal anywhere really. And that's really why. It's just rust. It's not as strong, breaks very easily, doesn't transfer heat very well, and that's why we talked about it in this webinar. Yeah, basically it consumes the pipes, the metal pipes. If we use plastic pipes, we would have other problems.
There's another question from Ariadne here. Would the place that the data center is in have an influence in the waste of water? Both its location in the world, depending on where it's located, the data center, would it have an influence then on water usage, I suppose, and waste, in terms of how much water you need to use?
Yes, because like the cooling needs, like a major factor in the cooling needs is driven by the local environment. Well, depending, yeah, in some situations, the cooling needs will be in part be determined by the local environment. So yes, wherever you place the data center, you might need more or less cooling, and depending on that, you might waste more or less water. That's like what I was saying earlier, like you could have these huge data centers in dry climates that could save a lot of water, but yeah, you need those specific conditions in order to have that.
Okay, we have another one here from Leo. Is there a total amount of water your company has saved around the world? Could there be an estimate?
Oh, I'm sure there is an estimate online, but I don't have it. Oh,
a lot of million of gallons.
I'm pretty sure there's even like a counter on their website. But
yeah,
I'll have to look it up. Like it's gotta be a lot, but I don't know. I don't know the number. Maybe I'll keep looking on their website, see if I find it. But
okay. Any other questions from our audience here? Anybody else from my ESS classes want to ask any questions? No? Okay. All
so right, just a quick Google search tells me that in 2018, this is 1 year, companies saved 188 billion gallons of water. I don't know how much that is in liters.
3 times more or less.
Okay. So yeah, like nearly 600 billion liters, 500 to 600 billion liters of water. It's a lot, yeah.
I know, yeah, from one of the videos they said that the water that was saved from the steel mill in India could service New Delhi city like it could service them with water, the amount of water that was saved. I can't remember the figure neither, but it said it could service the city. Another question from Marietta: how many years has 3D tracing been working? I suppose in operation. When did it start as a technology, or when was it developed?
I'm actually not sure when it was implemented. I know one of the patent that has like the fluorescence tag, that's publicly available, and I think that was published in 2001. But if that was 2001, I don't think the technology would have been deployed then. It's probably somewhere in the last 10 years, I would guess. I'm not exactly sure.
Okay, so it's not recent technology. It's been around for a while, but I suppose it's getting more popular, like you said, as data centers
Yeah,
are developing.
and especially with the increase in also like artificial intelligence and all that also makes this whole data analysis more attractive too.
Okay. Alejo, here is a question: do you believe that we can make a change? We're not many to change the world. I'm not sure if that's related specifically to the technology. I suppose make a change, maybe our viewing habits on Netflix. Maybe we need to cut back, and we can cut back our water footprint.
Even our innovation, or also like cultural habits, yes, but also probably the one thing that we most can do to improve the environment is probably just remember, maybe students are probably too young, but once you have the ability to vote, always keep in mind environmental policy, because structural change is what would matter more than individual action.
Okay. Leah, was the question here: what was your first impression when you first heard about the 3D Tracer project?
This is gonna be a little funny because I first learned about it when I was an intern at Ecolab at a pilot plant, and my project was like the processing of tacky solids. So some of these products are actually like very sticky products, and processing them was very complicated. And that was my project, just like finding ways to process these very sticky materials. And one of them was like this 3D tracer polymer. So my first impression was that it was very sticky. It was just sticking to all the walls of the equipment processing. And yeah, that was my first impression.
A bit like Slimer from Ghostbusters. Okay, Leo, does that answer your question? Yeah. All right. I'm sure, I don't know if we have any others. Okay, Leo, thanks. All right, I think that's all our questions for this evening, although we have one more. Have you faced any issues while working for the 3D Tracer project? Okay, John, you might have to elaborate what issues. I suppose, was there ever a time when the system just failed, malfunctioned itself, the 3D Tracer technology maybe thing? Has that ever happened?
Sorry, can you repeat that?
Jan had a question here. Have you faced any issues while working for the 3D Tracer project? I'm not sure what Jan means by this, but perhaps maybe like the actual technology itself, has it ever failed, perhaps?
Oh, I'm not familiar in that sense. I'm sure it fails. Like I'm sure it has failed in situations like every technology. I'm not really familiar. But one of the things that this has, like I said, it's actually like a control center that it's like monitoring the technology and like the water quality. So if there's a problem, at least someone in the company would know and would send someone to try to fix it, figure out what it is. But yeah, I'm sure there have been problems. I just don't know the specifics for that.
Okay, Antonio has another question here. According to the official website, the water that has been saved since the beginning of the project is equivalent to the yearly drinking water needs of more than 4.4 billion people. So he's Googled it as well.
Good.
Okay. All right, I think that's all our questions. And no one else seems to be popping up. Okay. Some nice comments coming through there. Okay. I don't know if Ms. Garcia wants to say anything before we finish. I know that you were in Ms. Garcia's first tutor group, I think, when she started at St. Peter's. Is that right, Ms. Garcia?
Yeah, that's right. So when Rebecca says that she's very proud, actually I have to say that so am I. It's like, you know, this big getting so like, oh yeah.
You followed in her footsteps. You listened in science and chemistry class, Marcello.
Definitely. Yeah, we wouldn't be here if it wasn't for Miss Nuria, for sure.
No. But anyway, I mean, I have to say that it's been a great talk, that you've timed it perfectly so that we could have actually everyone's participation and asking, and I'm also delighted with the students' participation because I think that they've been really into it. And I'm sure that I'm gonna get some questions as well. At the moment I'm doing physics with them, but some of the questions that actually Jan was asking will be dealt with when we do chemistry about corrosion and when we talk about the different types of bonds. So Jan, keep that in mind, that we will come back to it. But thank you very much, Marcello. I mean, it's been a pleasure, really.
Yeah, it has been, especially because you broke down quite a complex topic, I think, for our kids, and it's a complex technology, something that they haven't learned about before, but you explained it really with a lot of clarity and conciseness. It made it easy, I think, for our kids to understand at their level as well, this type of technology. And it's opened up, I think, their eyes as well to, you know, other types of technology that are out there, and maybe jobs even for them for the future as well. You know, data centers are growing every day and they're popping up in places every day with more people working online. So definitely, thank you very much, and thanks for taking your time today from your work. I'm sure you're busy, or you might be glad of the break, especially working from home.
Yeah. And I should mention, if anyone in the audience like really wants to learn more about the specifics of cooling, like HVAC systems in data centers or in general, there's a really good YouTube channel that's called The Engineering Mindset. I would highly recommend it if you really want to learn more about the cooling systems themselves and data centers and all that, like data centers designs for cooling. It's a good YouTube channel for that.
Okay. Okay then. If we leave it at that then for today, or else if you have what someone's just asked again, what's it called?
I'll type it. I think it's called.
Or even if you give the link for the website, even, and if you share it in the chat, they can copy and paste it then. Engineering Mindset. I'll give it to them as well in class again, so I will just write it down myself. So if they want to learn more, they can go to that website.
Yeah, and that's more about like the specific cooling systems that I didn't describe how they work and all that. If they want to learn more about that, that's a good research for that.
I'm sure that they are also really interested in it, but not because of what you might be thinking of the engineering, but there's also a few here that are really into robotics and data management. So I suppose that even just as consumers, they are interested.
For sure, definitely. Okay, all right. We might leave it at that then for this evening. Again, thank you very much for your time today. I'm sure you're busy in work as well at the moment, and it was lovely to meet you. I met you a couple of weeks ago and I got some insight into your job and how you arrived where you are. Any advice that you'd like to give the students before we log out today? College advice, or choosing subjects or careers, or, you know, because your job has changed. You did chemical engineering, but now you're in logistics, so your role has kind of changed in the company as well. And I suppose at this stage they're worrying about subjects next year, and they think they have to choose their lifelong career right now. And, you know,
my main suggestion would be to explore and don't be afraid to change your mind in the future. Just explore as much as you can, try to find what you like, and hopefully that leads you to things that you like.
Okay,